When you look at a beautiful, sparkling gemstone, what do you really see? Because it's so much more than just a pretty rock. It's actually the very last page in an epic story, a story that begins hundreds of miles under our feet and takes millions, sometimes billions of years to unfold. So today, we're going to uncover Earth's incredible, secret recipe for creating these amazing natural treasures.
We've all seen this, right? It's that classic pop culture moment. Superman takes a lump of coal, gives it a good squeeze, and boom, a perfect diamond. It's a really simple and powerful idea. And honestly, for a long time, it's how a lot of us thought diamonds were made. But the truth? Well, the truth is way more interesting.
Yeah, that whole idea is pure Hollywood. It looks great on screen, but geologically it just doesn't work. The science is pretty clear. Coal comes from ancient plants, and it forms pretty close to the Earth's surface, in the crust. Diamonds, on the other hand, are born in a totally different world, under the insane pressure and heat of the Earth's mantle hundreds of miles deeper down.
So, okay, if the coal story is just a myth, what's the real story? Well, it turns out the actual process of how a crystal forms is way more fascinating than any superhero tale. It's this incredible story of chemistry, geology, and just unimaginable stretches of time. The easiest way to wrap your head around how any crystal grows is to think about making rock candy. Seriously, you just dissolve a ton of sugar in hot water until the water can't hold any more. Then, as it cools down, the water has to let go of that extra sugar, and it starts to crystallize, molecule by molecule, onto a string. The Earth does the exact same thing, just on a geological scale. Instead of a jar of sugar water, you've got a pocket of superheated, mineral-rich fluid deep underground. So for Earth's recipe to work, it needs 5 main things. First, you need the right ingredients, like carbon for diamonds or aluminum oxide for sapphires. Then you need an incredible amount of temperature and pressure. That's what dissolves the ingredients and then forces their atoms to line up in a perfect crystal structure. And finally, you need 2 more things: a little bit of space for the crystal to actually grow into, and an almost unbelievable amount of time. We're talking millions of years. Now, what's really cool is that the Earth doesn't have just one kitchen for this recipe. It has a bunch of different geological factories, and each one has its own unique cooking conditions. And these different environments are what give us the amazing variety of gemstones we see. So let's take a look at the 3 main types.
This really breaks it down. First, you have igneous gems, like topaz, which literally crystallize out of cooling magma. Then you have metamorphic gems, which are all about transformation. An existing rock gets cooked and squeezed under intense heat and pressure until it becomes something totally new, like a ruby or a sapphire. And then you have the mantle gems. These guys, like diamonds, are born under the most extreme conditions you can imagine, over 100 miles deep in the Earth.
But here's the kicker. Creating a perfect crystal deep inside the Earth? That's just chapter 1. That gemstone still has to survive an incredibly violent and super long journey, all the way up to the surface, where we can actually find it.
And believe me, this trip is not a gentle elevator ride. It's a brutal, chaotic process that really only happens in one of 2 ways. One is ridiculously fast, and the other is, well, it's unimaginably slow.
For diamonds, it's all about the fast lane. We're talking about deep, volatile magma that erupts and rockets towards the surface at insane speeds. And that speed is absolutely critical. See, if it were any slower, the changing pressure and temperature would literally cause those diamonds to change into graphite. Yep, the same stuff in your pencil. This crazy eruption just rips through the crust, carrying diamonds along for the ride and leaving behind this carrot-shaped geological feature called a kimberlite pipe. For a lot of other gems, though, like rubies and sapphires, the journey is the slow road. Instead of a volcanic blast, their trip to the surface depends on the massive forces of plate tectonics. You have 2 continents colliding, and over eons, the pressure literally shoves these gem-bearing rocks upwards, bit by bit, forming enormous mountain ranges. But even after the mountains are built, the work is far from over. For millions of years, you have wind and rain just beating down on that rock, slowly wearing it away. It's this incredibly slow, steady process of erosion that finally uncovers the precious gems that were hidden inside. So, once these tough little crystals are broken free from their host rock, they start the final leg of their journey. And this is the part of the trip that concentrates them into places where we humans can actually find them.
And that brings us to a really key idea in gem hunting: the placer deposit. Now, that sounds fancy, but it's really just a spot where heavy minerals, like gems, have been naturally collected and concentrated by the elements. And for thousands of years, these deposits have been the most important source of gemstones for all of humanity.
So how do they all end up in one spot? Well, the secret is water. You have to think of a river as this giant, natural sorting machine. As the water flows, it just washes away all the lighter stuff, sand, silt, dirt. But the heavy, durable gemstones, they're much harder to move. They get left behind, settling in riverbeds, or at the bottom of waterfalls, or on the inside bend of a stream.
This is exactly why only the toughest and heaviest gems are found this way. I mean, they have to survive being tumbled around in a river for ages. That incredible durability is why stones like diamond, sapphire, and ruby are the ones you almost always find in these rich alluvial deposits all over the world. So now that we understand Earth's billion-year-old recipe, it brings up a really fascinating modern question. What happens when we, humans, figure out how to copy that recipe in a lab?
Using some pretty mind-blowing technology, scientists can now replicate the same intense heat and pressure that you'd find deep inside the Earth. But let's be super clear here. They're not making fakes. They're creating synthetic gems that have the exact same chemical makeup, the exact same crystal structure as the natural ones. The only real difference is the timeline. They've managed to shrink a million-year process down to a matter of weeks.
Here's the difference in a nutshell. A natural gem, it carries the chaotic story of its birth inside it, often as tiny imperfections we call inclusions. They're like geological fingerprints. A lab-created gem, though, is grown in a perfectly controlled environment, so it's usually flawless. One is a total product of chance and time, which makes it incredibly rare. The other, well, it can be made whenever we want. And this really brings us to the ultimate question. If a lab-grown gem and a natural gem are physically and chemically identical, what is it that we truly value? Is it the perfect, flawless crystal? Or is it the rarity, the history, and that incredible billion-year-old story trapped inside? That's definitely something to think about.